Unoptimized images is one of the worst performance killers of your application. That's why in this video I'm gonna show you a solution that can help you fix this problem by dynamically resizing and optimizing the images that are being displayed in your application. In the end, you can get benefits of up to 1000% faster load time in the application. But actually, instead of me telling you this, let me actually show you, because this problem with slow loading images is very common, especially in applications that have user-generated content. So here is a before scenario, and I'm trying to just render a simple screen, something similar to Instagram, with a grid of posts, some profile pictures, maybe some pictures of people who are following. And this loading speed is in real time, and as you can see, it's super slow. It not only increases the amount of data that is being downloaded, because in total all of these images were 88 megabytes, but it also impacts the user experience because you have to wait 15 seconds just to see all the images loaded. Well, we're gonna fix this issue, and at the end, our application will load like this. I'm not sure if you saw it, but it didn't even blink. Like the images appeared instantly just because they are optimized and they are the right size displayed. So in the end, our application rendered in less than 100 milliseconds. As you can see here, it took around 1 millisecond for every single picture. And in total, we downloaded 419 kilobytes. So real quick to show you before, it was 15 seconds and 88 megabytes. That's actually 99% faster. And I think it's it's probably 1000 times faster to load the images and less data being loaded on the end user device. So that's the solution that we're going to build today. This solution is designed for any kind of project that is storing the images in an S3 bucket. So if you're using S3, it doesn't matter if it's a web or a mobile application, you're going to be able to implement this solution on AWS to optimize your images that are stored in S3. So we're not going to use any third-party providers. Everything is going to be directly on AWS, and we're going to take advantage of a pre-made solution so anyone will be able to follow along. In fact, the whole solution will take probably less than 30 minutes because we only have to configure it with our own project. So anyone with no matter your experience, will be able to implement and improve the performance in your application. When it comes to the front end, as I said, this solution is front-end agnostic. It doesn't matter if you're using React, Vue, Angular, React Native, or anything else. I'm going to show you an example inside React Native, but the front-end side is really minimal. Like it's a couple of lines of code to build a URL, and then you can serve that image anywhere in your application. So the agenda for today, what we're going to do is, first of all, we're going to deploy the solution on AWS, and it takes literally one click to do that. We're going to then explore the demo UI to see how it works, to play with it and make sure that the solution actually is working. And after that, we will be ready to integrate it in a client-side application. In this case, I'm going to show you how you can do it in React Native. After that, I'm going to also explain you the architecture, and I'm going to explain how everything works behind the scenes so that you understand it better. And also I'm going to cover the pricing at the end so that you know what to expect. And by the way, it's way cheaper than using third-party providers. But more about that at the end. So if you're ready, I'm ready. Let's roll the intro and let's get started. Before we jump into the implementation, I want to say a big thank you to the sponsor of today's video, Stepzen. If you haven't heard of Stepzen, Stepzen is a unique GraphQL server that allows you to build GraphQL APIs really easily, and you get an optimized and a very scalable API out of a box. So the way it works, you can connect Stepzen to different data sources, starting from SQL backends like PostgreSQL, MySQL, also to REST APIs. For example, if you have a REST API, you can create a GraphQL layer on top of it with one line of code, and to other GraphQL backends. If you're interested to learn more about that, make sure to follow our LinkedIn clone that we're doing at the moment. This Friday, we're going to do the backend side using Stepzen, and there you'll learn more about the benefits and how easy it is to build GraphQL APIs. Thank you very much, Stepzen, for making this video possible. And if you're ready, I am ready. Let's go ahead and talk about the prerequisites that we're going to need and right away start working on it. So here I prepared the prerequisites. You're going to need an AWS account. It's free to create one. You have a free tier, but more about pricing, I'm going to talk about it later. I have prepared also a step-by-step guide on our website. So go ahead to notjust.dev blog AWS image handler, and there you should find all the steps that we're going to have to take today, including the asset bundle. The asset bundle will contain, first of all, this presentation that can help you serve as a step-by-step guide to implement it in your project. And also I included there the starter project that we're going to use today, and also the final component that will render these smart images. So make sure to download the asset bundle as well. All the links you can find in the description below. And yes, with that being said, hello everyone from the live chat. Let's go ahead and open up the page for this solution. So what we have to do is go ahead, open the serverless image handler inside the AWS Solution library. Because as I said, this is a pre-made solution. It's a CloudFormation stack that we can launch inside our AWS account. And this stack was created by AWS professionals. So in the end, it's a very secure, scalable stack that can help us get started with this. We don't have to know all of the things that goes behind the scenes. We can simply launch it, connect it with our application, and benefit out of it. Anyway, I'm going to also explain you all of this architecture, how it works, and why it works so well. But to launch this stack, it's very simple. It takes one click of a button. So if you follow that link, I also included it here in our blog. Here in the right panel, we can go ahead and to scroll to the deployment options. Here in the deployment options, we can press on the button Launch in AWS Console. And what this will do is it will go ahead, and I'm already logged in my AWS account. If you're not, make sure to log in or create an account if you don't have one. But probably if you're watching this video, you have an AWS account. And that button redirected us to the CloudFormation AWS service that allows us to create AWS tags based on predefined templates. So on the first page, the only thing that we have to do is press next, because everything else is pre-filled with the URL to this serverless image handler template. So we don't have to touch anything here. Let's press next. In the next one, go ahead and give it a name. You can leave it as serverless image handler, or you can provide here more details about your project. And let's go ahead and select some of the only important parameter that we have to change here for this to work is the image sources. Here, we need to specify the name of the buckets where our original images are stored. So if I'm gonna go ahead in S3, Here I'm gonna see a list of buckets. If you are using Amplify, you might see something like Amplify like this, or go ahead in your AWS config file from inside your project, and there you'll find the name of a bucket where your objects are stored. The bucket that I am going to use is called something with dummy data. I think I will have to, yeah, it's this one. That includes some images for the dummy data. And here I prepared some high resolution images that are basically 1 to 4 megabytes. And this is usually the sizes of images that users are uploading from their phones. So inside these buckets, let's go ahead and copy the name of a bucket. And back in our CloudFormation, here inside image sources, we're gonna delete the default ones and enter the name of our bucket. If you have multiple buckets that you want to add this image handler for, you can add them as comma separated, but for us, one bucket is enough. Let's leave everything else by default, and let's go ahead and press next. Here we can add some tags, but that's not the most important. And on the last page, let's press next. And here to confirm everything, let's scroll down. I acknowledge that AWS CloudFormation might create YAML resources and submit. All right, that was everything that it took for us to start initializing this stack. And now what we're gonna see is this create in progress. You're gonna see a list of events, and we're gonna have to wait around 4 to 5 minutes until we see that the last thing is in create complete status. So while it's still creating progress, we're gonna have to wait for a bit. So stay patient. And actually I'm going to maybe move it here. Not here. Here. Yeah, I think this way it's going to be better. Okay. We can from time to time refresh this, but yeah, like as I said, it should take around 3 to 4 minutes. Not sure what's going on. Stacks here, the last one. And in the events, we're gonna see the it's a bit weird when I'm zooming so much. Somewhere here. Events, yes. Oh yeah, it should be like this. Yeah, so now CloudFormation is initializing all the services that this solution depends on inside our own AWS account, and is connecting them together in order to make it accessible for us. Yes, as I was saying, this solution is especially important for applications that have user-generated content. For example, if users are allowed to upload images inside your application, then most probably your application has these performance issues. Because whenever the user uploads an image from his phone, that image is usually a couple of megabytes large. It's a very large image. And whenever we are displaying it inside our application, if you're trying to display a 4K image inside a circle that is a size of 50 pixels by 50 pixels, like in the case of these followers, in that case, you are wasting so much data by loading the original size high quality image. So a better approach, like as you can see here, if I'm gonna refresh this application, it takes quite a lot of time to load them. It's real time, like as you can see, like it's that slow. But if we change to smart image here in our code, and that's what we're gonna do in a moment, if I refresh, as you can see, it's instant. Like I don't even see like any flickering. It feels like the images are displayed even faster than the static text that we see here. So the quality didn't decrease too much. Maybe we can be more generous here and have even a better quality, because there is a lot of room to increase the quality from here. But anyway, like everything looks the same, but it's loaded. The images are loaded with the right size. For example, these profile pictures that were in total, I don't know, like 20 megabytes. Now they're a couple of kilobytes, because all of these profile pictures, they should be 30 by 30 pixels, not more. That's what we have in our application. So that's an optimized way to show the images. So the idea of this video actually was generated from the startups that I'm advising. So a couple of them had this problem where the application felt very slow. The images were loading very slow, like you would open the feed and you'd have to wait a couple of seconds for the profile picture, for the images in the feed to load. And they asked me, like, how can they improve this, the speed of the application by optimizing the images. So I decided to do this video for them and also for you guys on YouTube, because I believe this can be helpful for you as well. So yeah, if we go back to our CloudFormation here, we see that the last one, serverless image handler, is in create complete status. So that means that everything has been created and we are ready to test it out. How do we do that? Let's go ahead and press on the Outputs tab. And from here, we are going to see a couple of variables that the stack output gave us back. One of them is this demo URL. Let's go ahead and open the demo URL in a new page. And what we will see is a user interface that was deployed for us to test our resizing solution. So this is a great way before we integrate it inside our own application. It's a great way to test it out, to make sure that everything works, to also try to play around and understand how the solution works. So what do we have to do here? In the image source, we need to provide the bucket name. So the bucket name, in my case, was notjust.dev dummy. And the image key, go ahead and actually navigate inside your S3 bucket to an image. For example, this one.jpg. From here, you're gonna see the key. So let's copy the key of this image and let's paste it in the image key here. Let's press import. And if everything works, we should see the original image being displayed here. If something didn't work, make sure you follow along and the configuration that we provided at the beginning, make sure that you didn't touch the default values, and maybe the names of the files and the key should also be important. Another limitation that I'm going to talk about later is try some standard extensions for your images like PNG, JPG, and so on, because the hake.hake extension from iOS, it's not supported here. So if the image is not loading, make sure you're working with PNG or something like that. Anyway, so that's our original image. That means that our solution is able to access the data from the S3 bucket. Now the second step is to specify how do we want to edit this image. For example, we can provide here the width of, I don't know, 50 by 50. We can enable the resize mode, and here we can choose probably cover in order for the image to cover the whole 50 by 50 square. And if I press simply preview right now, we're gonna see the image 50 by 50 here. So if you open it in a new tab, if you download, you're gonna see that it's actually 50 by 50. And yes, that's how easy it was. There are some other things that you can play with here. For example, if there are different resize modes, so if we have width maybe 100 and height something different than the original image, if we're gonna do preview, it's gonna be cut like this. Maybe you want to change the resize mode from cover to contain, and in that case it's gonna contain here, but in this situation you also can provide the fill color and the background color, like, I don't know, 1 2 1 2 1 2. What's gonna be that? I don't know. Or should it be the fill color? It's a gray color, and here we see the green color. Anyway, if you leave the height empty and only provide one dimension for the width or only the height, in that situation the aspect ratio will be kept the same, and only one part will be changed, like the width, for example. So this is very good when you want to resize the images but keep the aspect ratio. You can also do some different changes, modifications to the image, because behind the scenes, this solution is using the open source library Sharp for processing the images. So a lot of things and a lot of configuration that is available in Sharp, we can use here for our request and configuration body for the image. For example, we can go ahead and make the image grayscale by sending here a new property grayscale, and that's gonna make it grayscale. We can flip it, we can flop it. What does flop mean? I don't know. Oh, okay, I understand. It's like in a mirror. You can make it even negative for some reason if you need that. So yeah, there is a lot of things that we can do here. I'm gonna remove this fill and background color, and let's do preview. Okay, that's better. Now, what's the... Yes, what we have done so far is we deployed the solution, we configured it properly, we deployed it, we waited, and we played with the demo UI. The next step is to integrate this solution in our React Native application and to basically request optimized images, the same way as we are doing here with the demo UI inside our application. So how does that happen? Do I explain it here? No, I don't. So how does that happen? How do we actually implement this? As you can see at the end, the demo UI gave us an encoded URL. So if we go ahead and access this encoded URL in a new tab, we're gonna see that it actually, this URL contains everything that we specified here inside our editor. So now if I'm gonna copy it, we should see that it's an image, grayscale image. Okay, perfect. So as we can see, the URL, this URL is very important because the first part is the URL of the our CloudFormation, basically the global CDN that we have to access our images. But the second part, which looks like a very weird string, this is in fact a base 64 encoded version of this object at the top. So everything that we provide here in the object is going to be encoded and added to the URL. And the cool thing about this is that sending a second request with the same parameters will not trigger will not do the job twice, because the object, this request with these options is being cached in the CDN, and it's only executed on the Lambda side only once. So that's something to understand. Maybe when I'm going to talk about the architecture, it's going to make more sense. But what I wanted to say is, in order to integrate it inside our application, there are a couple of steps that we have to do. First of all, is to define this request body that has three properties: the bucket, basically the name of a bucket, the key, basically the name of a file that we want to optimize, and an object with edits. The edits, you can play around here to get exactly what you want, where I'm going to show you the documentation to see what extra edits you can do, because these are not everything that you can edit in the image. This is the basic that you most probably will need. So after we create this object as a JSON object inside our application, we go ahead and encode it as a base64. You can do that in any kind of framework or application, JavaScript, and so on. And having that encoded, we put it together with a URL, and we can load the images inside a normal image component. So let's go ahead and implement that in our application. Actually, I'm going to close this and solution because I want to start from the starter project, the project that everyone has access to if you download the asset bundle. So let me go ahead and open it here. Give me just 1 second. So it should be YouTube, videos, and this one. So here we have it. Here we have the asset bundle that you should also have access to, and I included this the starter project zip folder. So let's go ahead and unzip it, and I'm gonna go ahead and open it in Visual Studio Code. Let me open a new window. And will it work like this? Yes. So here that our project is opened in Visual Studio Code, let's go ahead and install the dependencies by running npm I. And then npm start. So I think I just have to wait a second to stop the other server. Where is it? Come on. And start it here again. So npm start to start our development server. And here I can press I to run it on iOS. All the code for this application is inside this app.tsx. I mean, most of the things is inside app.tsx. And let's try to run it again. And I'm going to show you what's everything. Okay, so here is the application loading very, very slowly. And our application starts with a header. And this header includes the background image, this S3 image. Then it includes the profile pictures of a person, some bio, and after that, a list of users that are following me. This component is very important to optimize it because the images are very, very small, so you don't want to load very large images there. Anyway, this header is later used as the header of a flat list, and the flat list is what renders our grid view with 3 columns. So all the data is coming from the users.json here. I added some dummy data for you as well to test it out, to see how it works. Okay. And Yeah, the component that is being used for all the images at the moment in the application is called S3 image. The S3 image is a component inside our components folder, and this is an unoptimized component that will receive the image key from the S3 bucket and will simply concatenate the URL of the bucket with the image key inside here and will render a React Native image using that URL. And that's everything it does. Now let's go ahead and actually copy paste this S3 image and let's call it smart image. Let's call it smart image, and let's go ahead and actually change the name here. Smart image and smart image properties here. Okay, so here as well. So, as I said, the first step that we need in order to render these optimized images is the request body. So let's see how do we want to resize a particular image. For example, we will have to specify width, maybe height. The resize mode, it's most probably going to be cover, and we don't need grayscale, and I think that's all the edits that we need. So if I press preview, it updates this object here. So let's go ahead and copy it from here inside our code. So const image request equal to this object. I'm gonna save to get rid of the brackets to codes, and I'm gonna also adjust some of the things here. For example, S3 bucket here. I'm gonna put this one as the S3 bucket, and maybe I'm even gonna call it bucket. I mean, you don't have to, but I will just take it outside this image request. So the bucket is my bucket. Replace it with the name of your bucket. The key is going to be the property that this component receives the image key, because we need it dynamically from outside to be able to use this smart image, and by sending the image key and the width and the height, it will automatically do that. So what do we do with this object? Well, we have to first of all stringify it, because we need a string version of it. So I'm gonna wrap it inside JSON.stringify, and we put the whole object here. Now, having the object as a string, as I said, the last step is to base 64 encode it. To do that, I'm gonna have to install a library called buffer in React Native. So let's do npm install buffer like this. No version available for buffer. That's weird. npm I buffer. I don't have internet or what? Yeah, now it seems to work. So let's go ahead and import buffer from buffer. And here inside our smart image component, we can get the encoded version of our image request by calling buffer from image request dot to string, and here we can encode it as base 64. So now if I'm gonna, so now the last step is to go ahead and add the encoded part after the URL of our CloudFormation. You can take it from here, or you can go ahead in the CloudFormation, check the outputs, and here is the API endpoint. This API endpoint is how we can access the CloudFormation. So let's go ahead and do here const URL is going to be equal to this one. Maybe we can add the /advent here, because later on we can simply when rendering the image, we can simply concatenate URL and then the encoded image request object after it. So that's everything that we have to do. I'm gonna come back in a moment to improve it a bit, but now I want to test it out and see if it works. So let's go ahead in our app.tsx. Let's import the smart image from component smart image. I'm actually gonna go ahead and define a variable called image here, which will be equal to smart image, because this way I'm going to be able to replace the image with either S3 or with smart image. And inside the code, I can use this image component. Make sure you don't have it imported from React Native to be used from here. So every time I see S3 image, which is in 1, 2, 3, 4 places, I added the S3 image. And as you can already see, the application is loading instantly. The first query maybe took a little bit of time because, as I was saying before, the first time the image is being processed, it takes a little bit of time because the AWS Lambda is using Sharp to optimize the image, but then it is being cached in the CDN, and all the other requests to that image with the same options from your phone or maybe from any other user in general is going to be served from the cache, and it's going to be super fast. And that's why we see here, if I refresh the application right now, it instantly shows here. And if I replace back to with the S3 image, you're gonna see the difference. Yes. I always love seeing this difference and the impact. All right, so another thing that we can do here, maybe to improve a little bit, in order for this not to be recreated every time, maybe we can put it in a use memo. So if I pre-calculate the encoded URL once using the use memo, it's gonna be better for the performance of our React side, but this is very optional, like everything is going to be working fine before. So use memo needs to return a value here, which will be the value of our URI. So if I copy everything here, the image request and the encoded part from here, and what's going to be the URI? Well, the use memo should have this arrow function, sorry. What should be the URI? The URI should be the actual end result of a URL plus encoded. So let's go ahead and copy it from here and return it as URL from the use memo plus encoded. And here we can simply say source URI, because this URI is calculated inside the memo. And we can add the image key as the dependency of the use memo, and this way every time the image key changes, this use memo will recalculate the encoded version of the URI and will update it. So this way, if I'm gonna refresh, everything is perfectly fine, and our URI is only calculated once. Okay, so another thing that I want to make more configurable is the width and the height. We're gonna do that using the properties. So let's go ahead and add the width, not while, but width as a number, and also the height as a number. Because sometimes I only want to specify width, or sometimes I only want to specify height, I'm gonna make both of them optional with question mark, and let's go ahead and destructure them from the smart image properties as width and height. Now, here in our image request, instead of hard coding 100, let's give the width coming from here and the height also coming from there. So if I save right now, it still should work, but we lost the very fast loading images. because width and height is undefined and it simply renders the original one. To fix this, let's go back to app.tsx, and for every single image, you need to think about the sizes of that image. In some situation, it's super simple. For example, if I look at these followers that are rendered here on the screen, to define a fixed size and width for these images that are rendered here is easy, because we can look at the style followers image, and we see that this followers image will always be 35 pixels wide by 35 pixels tall. So we can go ahead to this image that is being used here, and we can provide the height 35, width 35. And now the followers, maybe the first time it doesn't improve, but if I do it again, it's again not improving. Why? Image, width and height, followers in the header. Let me go ahead and do console.log image or URI. Maybe I should also add the width and height as the dependency of this array. And if I refresh, maybe the actual images are loaded okay, but they are loaded after the other images that take a lot of time. So let's go back to app.tsx. And for example, for the image rendering our profile picture, right? This one, the avatar. If I look at the styles, the avatar will always be 100 by 100 width. So for the avatar image, I can go with 100, and I can leave it even like this because the height will try to maintain the same aspect ratio. For the image of the background, if I look at the background image, the width is dynamic, it's 100%. However, the height, it will always be 150. So I can go ahead and give the height 150 here, save. Yes, I already see that it's working because the quality decreased. Maybe for the header, the quality is too little, so maybe you can increase it a bit, like to 300, 400 or something like this. Yeah, now it looks better. And you have a lot of room to increase the speed without having these slow images. And what else? So image, optimized image has width, image has width and height. And then in the flat list, these images that are rendered in the grid, here we can specify the width of, I don't know, 300 pixels might be okay. Now, if I refresh, it still takes a bit of time. But the second time, that was the first time, but the second time when I refresh, it's already cached in the CDN. It's not cached locally. So this is very important to understand. I'm gonna open the debugger. And from Smart Image, I don't have to console log anything because it works. So in the debugger, we can have a look at the network requests that are being made. So if I refresh, maybe one more time, we see all the images being loaded. So as you can see, these, let me zoom in a bit. So these images are already not a couple of megabytes, they are 44 kilobytes, 43, 30, and so on. And the images of people who are following, they're super small and they are only, like this one is only 3.7 kilobytes. It took 1 millisecond to load. And I can even disable the local cache and the images will still load very fast. I can even probably uninstall ExpoGo from here, and the next time it's gonna open also fast because it's not necessarily cached locally, it's cached at the CDN level. So it's also like in a physical place where it's close to our application. So as we can see, the image is loaded, and now it takes like literally instantly to load them. So to recap, how do we integrate the processed and optimized images in our application? All we have to do is to create an image request that contains the bucket name, where to take the images from, the key with the key of the image, and a list of edits that you want to do on the image. After that, the object will be stringified and then encoded to base64, and it will be merged together with the URL of our deployed CloudFront, that we can take from the output here. And that's it. Then that URL can be used with a React Native image, where it can be used to be downloaded. You can do anything that you would do with a publicly accessible image there. So now our application is loading a little bit faster, I would say. All right, so that was the integration of the image handler in React Native. Let's see what do we have next. In the presentation, you have all of these steps with more code snippets that you can take a look at. And if you have an Amplify project, because on this channel we have done a lot of Amplify projects, there are two things that I want to mention here specifically for you guys. So first of all, if you have created the Amplify bucket, the S3 bucket using Amplify, you can also manually define the name here, but a better approach would be to take the name of a bucket from the AWS config. So AWS has that AWS exports file, which contains the user files S3 bucket. So by taking the bucket from that file, you dynamically take it from the configuration of Amplify. Next thing is the prefix. So with Amplify, here it's also depending on how you store the images, because if your image key that is stored in the database for the user avatar, for example, if it doesn't start with a public or private or secured, in that case you need to, when specifying the image request, you need to add manually the public here before the image key, because Amplify will create 3 folders in the root of your bucket, one for public files, one for protected files, and one for private files. So make sure to add the public at the beginning, and later on I'm gonna talk about the limitation, but long story short, this solution will only work with publicly accessible images. So yeah, if you're using Amplify, make sure to follow these steps as well. And yes, this is our result. It takes less than 100 milliseconds to load. 100 is probably too much because all of them are literally 1 second. And the total size is less than 419. Again, this depends on how aggressive you are with resizing the width and the height of the images. Sometimes you can do that quite a lot, like for example, for small images like this. Sometimes you want to preserve some quality. So if I'm going to check here for this one, in this case, it's less than 1 megabyte for all the images here. 25 images in the feed and more here in the header. Okay. So guys, we're not done yet. I also want to cover the architecture, some advanced features, and also the pricing. But if you enjoyed it so far, make sure to subscribe to the channel down below, because we are doing this kind of content every single week, project-based, mobile applications. So if you want to learn that, if you want to become a full stack developer, make sure to subscribe. It can take you literally 2 seconds and it will help us a lot. And if you do that, you are officially part of a 1% gang. And you can comment that down below in the comments, because from the analytics, only 1% of you watching this video right now are actually subscribed, which is mind-blowing. It takes you 1 second. So if you've done that, comment below the 1% gang. I will be very thankful to you. And yes, we can continue with our build. Here I want to specify a little bit, to talk a little bit about some of the advanced features. Some of this is the smart cropping feature. So how can we play with it? I'm going to show you how we can play with it in the demo UI, because this is the easiest way. And anything that you can do in demo UI, you can just simply adjust the request body in your application and it's going to work the same. So I want to load a picture of some humans. So I think Hormozy, or how is it called? So if I import, yes, this is a picture of a person standing. So the thing is that if you want to render the avatar of this picture, instead of reducing the width and size to, let's say, 100 pixels, maybe I can do it to 300 so you can see better. If I will do it like this, maybe not even giving the height to preserve the quality. Let's do it even smaller. Yeah. So if you want to resize this picture to show as an avatar, it's not that smart to simply crop it down completely or resize it completely. It would be smarter to crop it and focus on the face of a person. With this solution you can, and you can do that with a couple of options to your request body. To do that, go ahead and select Smart Cropping and add some cropping padding, like, I don't know, if you don't add it, what you're gonna have at the end is this small face. Preview. Yes. As you can see, this automatically smart cropped it and focused on the person face. It's a bit weird like this, but if you add some padding, like, I don't know, 50, it's gonna look better, and you can use this picture now for the avatar, because it's gonna make more sense for if you're building, like, for example, a social media application. This is working behind the scenes with the Amazon recognition. It comes with additional costs, which I'm gonna cover in a moment, but it's very nice to see that this thing is possible here. Anyway, so again, like, you can use this in your application by simply adding this smart crop and the padding 50. That's it. You can also choose, like, if you have more people, like, on which one to focus. That's optional, by the way. That is the AI feature of smart cropping to the people's faces by recognizing it and focusing there. Another thing that is powered by the same service, Amazon Recognition, which does image analysis, is the content moderation tool. So the content moderation tool can help you automatically detect images that are not safe for watch, like, for example, nudity, or even other filters that you can define there. So if you're building an application, I don't know, maybe targeted to kids, or even like any kind of application, if you start growing and if you don't have any content moderation in place, you'll very soon get weirdos on your application that will start uploading pictures that are not very safe for everyone to watch. And these issues, like, if you don't delete those posts manually, these issues can actually get your application removed from App Store, because it has this not safe for watch content. So with the next feature from the same solution that we have here is we can enable content moderation with a simple parameter content moderation true, and this will activate the content moderation, and it will how is it called, blur the image if the Amazon recognitions believe that it's not safe to show it. So actually, maybe we can, I didn't prepare a demo for this, but maybe I can do it quickly. So I know I will not show any like nudity, but I know that there is an option to also filter out. Where is it? I can open the implementation guide. I think for smoking as well, like there is a smoking images. You can hide things that people that are smoking basically. So if I'm gonna download this image and if I'm gonna upload it to the same high-res things, smoking, let me add it here. And I'm gonna make it publicly accessible. Okay. Now this content moderation, I cannot, let me just check if I can upload the image here, but I cannot add the content moderation from this demo UI. So we're gonna have to do it inside our own application. So let's go ahead and inside the code of our application, I'm going to add, inside users.json, I'm going to add one more post at the top that will have the image smoking. And this should be the latest image here. Yes, that's what we see. And in the smart image, if in the edits, I'm going to do, how's it called? Content moderation true. Content moderation true. Let's refresh and see what we have. It takes a bit of time because now it regenerates again because our image request has changed and it should go through the Lambda function again. And as you can see, just by doing that, the latest image is blurred and we cannot see it. So that's a super powerful feature for social media applications to automatically do content moderation. Yes, it comes with some additional prices, but it can save you a lot of time. And yes, the first time it took a little bit more because it went through Amazon recognition as well. But now if I'm gonna refresh, it's cached and it's rendered way faster. Anyway, I'm gonna turn down content moderation. I just wanted to show you what's possible. And I will also actually show you some details about this content moderation in this guide. Where is it? Use the solution. I want to show you what you can do basically with content moderation because I simply enabled it and it will moderate everything. But you can also specify exactly how you want to moderate. So yeah, if you simply do content moderation true, that will enable it. But there is also operations like minimum confidence to increase the threshold where the image will be blurred or not. You can also specify how much blur you want because you can maybe blur it not that much, as in our situation that was completely blurred. And this moderation label is also very important because moderation labels you can specify what exactly do you want to hide, because maybe you don't want to hide everything. Maybe in your application smoking content is okay, but nudity is not okay. So you can go to this page and you can look at the different labels for the moderation. There are top level categories and there are more specific. So you can specify you only want explicit nudity to be filtered from your application, or violence, or drugs, or tobacco, alcohol, and so on. Hate symbols, you can also do that. Rude gesture, middle finger, you can hide it as well. It's impressive. Anyway, this was the smart content moderation powered by the AI tool Amazon Recognition and how it can also help you with this solution. Another advanced feature is the Thumber, but I don't have a lot of experience with Thumber. The only thing that I know is you can specify different filters with it. So if you're interested in this Thumber compatibility, what you can do is you can specify these edits inside the URL, and I saw that how it can actually be very helpful is, for example, adding a watermark to all of your images. That's another cool feature that you might be interested in. Where is it? Come on, fun. Look, I'm not gonna stop here. I will only say that this solution supports like Thumber filters, and you can have like different things, like you can rotate the images, you can add different filters on top. You can also add watermarks and so on. So if you are interested in that, check out the documentation of the solution to find out more. Okay, now it's about the architecture. As we saw, we didn't need a lot of experience and knowledge about AWS to implement this solution. It literally took us a click of a button to spin it up, and that's cool and that's perfectly fine. But I also wanted to dive deeper a little bit in the architecture for us to understand what's behind the scenes and how this solution actually works, because it will help you better understand how to use it, how not to use it, how to adjust it maybe, or how to look into the implementation details, because you can do that as well. It's open source. So at the core of architecture, there are actually two main services. So the client will send a request, and the request will go through the Amazon CloudFront. Amazon CloudFront is a CDN, a global network of servers where that works as a cache for your data. For example, if your S3 bucket lives on a server on AWS in USA, and some users from Europe or from Asia are requesting that image will physically move through the wires from USA all the way till it gets to the user. So the speed will differ for a user that is using your application inside US compared to a user using it somewhere far from USA, because it literally takes more time for the bytes to travel through the wires. With Amazon CloudFront, AWS has a lot of servers all over the world, and the way it works is you put it in front of for example, a S3 bucket, and when someone is requesting an image from the CloudFront, it first checks if it has it there locally cached. If not, it will go to the source S3 bucket from US, it will download, it will give it to the user, and at the same time, it will cache it on that physical server that is closer to the end user, maybe from the same country. Maybe, for example, if a user from Germany joins the application, the image will be cached at Germany on a server that is in Germany. So the next time someone else, like another user, joins from maybe Belgium, it will come from the same Germany server, and it will take way less time to download the image because it's physically closer to you. So I think I'm going too much into details to these servers. Maybe if you're interested, I can have like separate videos about that. But long story short, Amazon CloudFront is a global CDN network that caches our images. Now, the second important part is on the right. It's the AWS Lambda function. The AWS Lambda function is using internally the open source library Sharp and is taking an image from an S3 bucket, is using Sharp to do all the optimization and edits on it, and then it gives it back to the Amazon CloudFront. So the logic of processing is happening in AWS Lambda. In between them, we have an Amazon API gateway that simply creates the endpoint and invokes the AWS Lambda function. It's like a middleware between the CloudFront and the Lambda that executes the code. These are the most important parts, but the whole solution has a little bit more services there. For example, if you enable smart cropping or the content moderation, AWS Lambda will talk with Amazon Recognition to process the images with these smart cropping and AI features. Here on the bottom, we have AWS Secrets Manager, and if your files that users are uploading, if they are encrypted inside your S3 bucket, you can specify the AWS secrets that are used for the encryption, and AWS Lambda will get them from there. And lastly, we have here an Amazon S3 bucket, and this is different bucket than the one where we store the images. This S3 bucket is used, there are actually two buckets. One of them is used for the logs, where Lambda will write all the logs, and another one is used for the demo UI. So it will only be there if you enable demo UI. So that's, in short, the whole architecture, how everything works. So the first time the user will request an image, it will go from Amazon CloudFront. It will see that the image is not in cache with that specific configuration. It will go ahead through Amazon API Gateway, will invoke the Lambda function. The Lambda function will read the image from the source S3 bucket where images are stored. It will use Sharp to optimize and edit it. If you enable smart cropping or content moderation, it will call the Amazon Recognition to do all of these AI things. Then, it will bring it back, will write the logs to S3 bucket and will give it back to Gateway. The Gateway will send it back to Amazon CloudFront, and the CloudFront will give it to the client. But the second time, the user requests the same image, it's going to go to CloudFront. CloudFront will have it already cached, and it will return it back to the client. So only the first time we invoked all of these services. After that, everything is served from a CloudFront, from a CDN. So that's why you saw that the first time maybe it takes a little bit of time for the image to be processed, but after that, it's right away being loaded, and it will not work only on our device, it will work once for everyone. Okay, so that was our small architecture. When it comes to pricing, that's also very important to understand how everything is going to be priced. It's important to understand that CloudFormation stacks that we launch on our account, we personally are responsible for all the charges that the services used in that stack will incur. So if we look at the previous architecture diagram, it's helpful for us to understand what services are being used behind the scenes, because this way we can understand what costs should we expect. AWS, this solution comes with an example diagram that gives you a little bit of ideas of how everything is priced. And here we have an example of, for example, having an application where users are uploading 100,000 new images every single month. So if your application has 100,000 new images every single month, expect to pay for the whole image processing around $15. And most of them are coming actually from the Amazon CloudFront, the CDN. But because we have a CloudFront, we are saving a lot of, first of all, compute power from AWS Lambda, because the Lambda is invoked only once, and after that only CloudFormation is doing the work. And without a CloudFormation, we would have to use Lambda for every single request. So the end price would be way higher. And the Amazon S3 for storing these images is very cheap, and the gateway as well is quite cheap, the secret manager as well. And you can see how it grows. For example, for 1 million images, expect to pay 10 times more, 150. And for 5 million, that's going to be around $752 per month. But if you're at that levels where your application is generating 5 million pictures every single month, I think you are in a very good situation, and $700 is not that much. I also want to mention that the services that are used for this solution, some of them, I mean most of them, are also included in the free tier. So when you create a new account on AWS, you get the free tier for most of the services, contain it for 12 months, and some of them are actually always there. So speaking about the services that we use in our application, expect to have like this amount of things for free. So every single month, you're gonna have 1 million Lambda requests for free. When it comes to the cloud front, you're gonna have always, every single month, you're gonna have 1 terabyte free of charge. And it's not only for the first 12 months, it's always. For the Amazon API gateway, again, 1 million API calls per month are free. And this is only for the first 12 months. And Amazon S3, 5 gigabytes of storage, free for the first 12 months. So I believe that if we go back to this pricing thing, the AWS Lambda for 100,000 images, this is going to be under free tier, so minus $3. The CloudFormation, it depends 1 megabyte per image. So if we have 100,000 images, that's less than 1 terabyte. So that's going to be for free. Amazon S3, it's going to be free. So for the first tier here, most probably you're going to pay actually $0 because most of these things are covered by the free tier. More information about the free tier and the services that are included there, you can access at awsamazon.com/free. And lastly, about the pricing is that maybe you saw that in this diagram, the Amazon recognition service is not included. So this is very important to understand, because if you're using smart cropping or content moderation, you are actually invoking Amazon recognition. And Amazon recognition is a paid service, and the pricing you can check here by following this URL. And I gave you a little example from the documentation is to analyze 1,000 images, it's around $1. And the more images that you analyze, the cheaper it gets. So use the recognition responsibly, because most probably this is going to be the most expensive part of your architecture, because everything else is quite cheap. Yeah, so that's the pricing. If you have any questions, let me know. Lastly, some limitations that I want to mention is, first of all, this solution is available only for public images. So images that are open to public, anyone can access them. They're not protected by authentication flows or so on. So that's important to understand. And also another thing is that this solution does not support the .hake images. And this is a limitation of the open source Sharp library used to process the images. And it's important because on iOS, a lot of images are .hake. So we would have to probably pre-process them, transform them to JPEG or PNG or something else, and after that, use them inside our architecture. And the Sharp supports this image format, so quite a lot. Anyway, that was everything for today. Super excited about this video. If you have any questions, let me know in the live chat or down below in the comments. I hope this video helped you improve the performance of your application. And if you have like an application where you have images uploaded by users, you definitely have some problems with image optimization. So this is a great solution that takes probably less than 1 hour if you do it back to back. Anyway, at the end, I want to say big thank you to Stepzen again for making this video possible, for sponsoring this video. Stepzen, we're going to integrate Stepzen in the LinkedIn clone this Friday. So make sure to join the live stream. It's already scheduled, or if you're watching this afterwards, the live stream is already on the channel. So you can watch it and learn how to build a full stack LinkedIn clone. Stepzen, thank you very much. And yes, let's see. One question we have here. I want users to see their data only. I was making an app with AWS Amplify React Native. I want to add authentication, but I want users to see their data only. How do I do that? You can do that from limiting like the permission of your API. So allowing only owners of the data to query it, to modify it, and so on. That's on the API level. On the images, you can do that, but this solution that I showed today is only working with publicly accessible images. So maybe it's not exactly what you need. Or you can adjust it. There is also the source code of this solution. Is it suitable for any size of application? Yes, this solution is very scalable, so it doesn't matter if you have 10 users or 10 million users. All of these services, they are serverless services, and they will scale up with the demand of your application. So it's perfectly scalable for any size of application. Okay, so thank you very much, guys. If you enjoyed this one, make sure to subscribe to the channel. We're going live every single Friday. This Friday, we're going to build the LinkedIn clone with Stepzen, and I'm going to see you there. Okay, thank you very much, and have a great day. Bye-bye.